Welcome back to the Dargslan series. We're at part 21, and phase 5 is where things get serious. This one's about monitoring, the difference between a project that technically runs and one you actually trust at 3 a.m. Because production grade isn't just, it works. It's knowing what's slow, what's failing, and what's quietly burning through your tokens. Over the next few slides, we'll build that out from 5 tiny pieces: logs, latency histograms, error rates, dashboards, and alerts. So why even bother? Because local AI fails in the worst possible way, silently. The model spits out garbage, the API cheerfully returns 200, and your status page stays green while users quietly lose trust. Think slow degradation as the disk fills and P95 creeps from 2 seconds to 12 over a week. Think a runaway retry loop melting your GPU overnight. And when someone asks why Tuesday was slow, without logs, you've got nothing. With logs, it's 1 grep away. So what do you actually watch? 5 metrics carry most of the weight. Request latency at P50, P95, and P99, because the median lies and the tails are where users suffer. Token throughput in and out, which is both your cost driver and your early warning for runaway tool calls. Error rate broken down by type, because a timeout and an need very different fixes. GPU, CPU, and RAM utilization to tell you if your model is the wrong size for your traffic, and cost per request, which locally means tokens times wattage times your electricity tariff. Surprisingly real once you're running a couple of 3090s. To capture those metrics, start with logs, and please structured logs from day one. Plain text falls apart the moment you try to answer, what was the P95 yesterday between 2 and 3? JSON per line fixes that. 1 event per line, 1 file, append only, and suddenly JQ becomes your best friend. The pattern here is 20 lines, a tiny log event helper that stamps a timestamp and dumps your fields, then a chat wrapper that tags every request with a UID, times it, and records tokens in and out. Wrap it in try accept, log the error on type, re-raise. That's your foundation. And once that foundation is in place, JQ turns your log file into a queryable database. No Splunk bill, no Datadog agent. Want slow requests? Filter where latency EMs is over 5,000. Need an error breakdown? Select error events, pluck the type, pipe through sort and Unix-C. 42 connection errors, 7 timeouts, done. Token spend per user is a JQ to awk one-liner, and P95 latency over the last hour is a sort and an array index. 4 questions, 4 pipelines, 0 infrastructure. But raw queries only matter if you know what healthy looks like. For Llama 3.18b on a single GPU under light load, expect most replies to land between 500 milliseconds and 2 seconds. That's your P50 fat middle. Around 5% will drift into the 5 to 10 second band. That's your P95 worth watching. Anything beyond 10 seconds should stay near 2%. The rule of thumb: P95 under 5 seconds, P99 under 10. When P95 doubles to 8, don't guess. Check disk swap, queue depth, and whether your model still fits in GPU RAM. Now you don't need Grafana, Prometheus, and a Helm chart just to see latency drift. 50 lines of Python gets you there. FastAPI serves a route. You slurp AI.log line by line, filter for entries that actually have a latency value, and let Plotly draw a histogram colored by model. Spin it up with Uvicorn on port 8000, hit /dash, and you've got a live view. Refresh the tab, see the new shape. It's ugly, it's honest, and it's 3am-Proof. That same approach scales to 5 tiny dashboards, each answering exactly 1 question. No kitchen sink boards nobody opens. Latency histogram by model tells you which one is slow. Errors per hour catches that 3:14 a.m. cron disaster. Tokens per user lasts 7 days, shows whose prompts are eating your GPU. Queue depth plus GPU memory, pulled from /API/PS, makes latency spikes self-explanatory. And hallucination rate, yes, manually sampled, 20 outputs a day, because status page green means nothing if users get nonsense. Dashboards tell you what's happening. Alerts decide whether it's worth waking you up. This little cron script is the whole pattern. Grep the last 5 minutes of errors out of your JSON log, and if it crosses 10, ping Slack. The real discipline is in those bottom comments. Be brutal about the wake list. Error rate, GPU, service down. Those are users hurting now. A P95 spike, one slow user, a disk at 70%. Those wait until breakfast. That's the 3 a.m. test in 2 lines. Speaking of discipline, let me save you some pain with 5 traps I've actually fallen into. Logging the full prompt feels harmless until a user pastes their API key. Keep prompts in a separate short retention debug log. 100 metrics with 0 alerts is just wallpaper. Pick 3 that wake you and mute the rest. Let AI log grow forever and you'll get a surprise outage from a full disk. Watch P99, not the median, because the tail is where users churn. And put a record on every log line. Without it, correlating across services is genuinely impossible. Now, AI log plus JQ will carry you further than most people expect, but there are 4 moments when it's time to graduate. When your AI workload spreads across 3 or more machines, move to Loki and Grafana. Same log shape, just centralized. When a 5-minute cron isn't fast enough and you need sub-30-second detection, bring in Prometheus and Alert Manager. When non-technical teammates need to see token spend, give them a dashboard, not a JQ incantation. And when compliance enters the chat, you need immutable retention-governed storage, S3 with lifecycle rules, or Loki tuned for the long haul. All still self-hosted, all still yours. So before you graduate to any of that, here's tonight's homework. 4 small jobs, 30 to 60 minutes each. Drop a log event, wrapper around every ollama call, every tool call, every RAG retrieval, writing JSON per line into AI.log. That's the foundation. Save 5 JQ one-liners in a runbook, slow requests, errors by type, top users, P95 latency, hourly error count, so you're not improvising at 3 a.m. Stand up a 50-line FastAPI plus Plotly page with 1 latency histogram, and wire exactly 1 Slack alert, more than 10 errors in 5 minutes. 1. Tune the threshold for a week before you even think about adding a second. Now, before you go and build all that, a quick reality check. Monitoring is overhead, and there are 3 cases where it's genuinely overkill. Solo prototype on your laptop? You're the only user, you see the stack traces in your terminal, AI log is plenty. One-shot batch job that embeds 1,000 docs overnight and exits, print progress, save errors, move on, no dashboard required. Air-gap deployment with no internet and no Slack webhook? Errors to stder plus a cron email is honest engineering. Don't pretend you have Datadog when you don't. So with that caveat parked, let's pull the whole part together. 5 takeaways. Local AI fails silently. Wrong answers still return 200, and without logs, your users tell you first. 5 metrics cover 95% of incidents. Latency percentiles, tokens, errors, hardware, cost. JSON per line plus JQ beats most fancy stacks. Loki and Grafana are a graduation, not a starting line. 1 brutally tuned alert that passes the 3 a.m. test beats 10 flaky pages. And a 50-line FastAPI dashboard you actually read beats a Grafana board nobody opens. Boring infra wins. And because takeaways fade, here's the cheat sheet. 12 patterns worth screenshotting. Left column is your data plane. 1 append-only AI.log, latency in milliseconds with P50, 95, and 99, an EAR type field for fast grouping, a tiny Plotly histogram, sub-30-second detection, and 20 sampled outputs a day to catch hallucinations. Right column is the operational glue, rec ID everywhere, tokens in and out for cost, JQ as your query engine, log rotate from day 1, 1-tuned Slack webhook, and the rule that wakes you only when users are actually hurting. Save the page. And that closes. Part 21, observability is online, 21 of 24 done. Next up is the capstone, Ask My Docs. Everything we've built since Part 11, the tuned RAG, the voice layer, the memory store, the OpenAI-compatible API, and now this monitoring stack, all wired into one real product that answers questions from your own documents, locally, privately, free. That's the thing this whole series has been building toward. See you in part 22.